So as you probably have read in the event summary, every machine learning application starts from a problem, and the problem we chose in this talk is using machine learning to predict when is the best time to buy Bitcoin. So before I talk further about this, I have to say that I personally do not endorse investing in Bitcoin for various reasons. So today we are going to use the Bitcoin as a hypothetical problem from where we can talk about data science in a more practical way. And I will introduce some of the features of Amazon SageMaker and how they can make data scientists' life easier. And most importantly, we are going to introduce a fully automated machine learning pipeline on AWS. So if there are some topics you are more interested in than others, you can type in the chat and let me know. Maybe I'll talk a little bit in depth into that topic. So secondly, you may ask, so why do you choose Bitcoin if you don't even like it? So there are several reasons I chose Bitcoin as a machine learning problem. First of all, for Bitcoin, there are quite a few like really good real-time data sources available. So the data is widely available. Secondly, the transaction in Bitcoin is very frequent. So at the beginning, actually, I tried to build this this pipeline using the British sterling transaction data, but the price itself does not change so frequently. And lastly, most importantly, the price of Bitcoin fluctuates a lot, and as many of you know, it's very unpredictable. So it makes a perfect case for automation. So why we are going to talk about automation? So as many of you probably are already very familiar with this machine learning workflow. So you have raw data, and then you perform feature engineering on this raw data, and then you train your model, and you tune your machine learning models, and finally you get a model and deploy it for prediction. So in many people's mind, myself initially included, we tend to think once a perfect machine learning model is defined, we can just use it forever. But of course, that's not always the case because the context of the problem is always changing. For example, for a recommendation system, people's behavior always change over the time. For example, a year ago, no one could predict toilet papers can actually be sold out, but here we have been. So in the case of Bitcoin, it's the same. We need to frequently go back to from the prediction model and go back to the raw data and redo the feature engineering, model training and tuning, and so on. So next, I'm going to talk about how we solve this problem. So first, from a machine learning perspective. So as you probably know, there's always more than one way to frame a machine learning problem into the language of machine learning. Although we already know the machine learning problem here was to predict when is the best time to buy Bitcoin. There are still several ways we can frame this problem. For example, because the nature of the Bitcoin trade price data or trading data is a time series data, so we can naturally frame it as a forecast problem. So we can forecast the trend of the Bitcoin price in the future. And more often we see people frame it as a classification problem. So essentially we are predicting in the future the price is likely to rise or fall. So the answer to this classification problem will be something like yes or no, and how sure I am it's going to rise or fall. And even within the classification problem, we can frame this, we can use different algorithms. We can use logistic regression, where our predicators could be the price or other trading indicators like the trading volume. We can also use a clustering algorithm. For example, we frequently hear people talking about some robotic trading algorithm analyze the latest news, and based on the news sentiment, they decide how to trade the stock, or in our case, Bitcoin. And also we can compare with other indexes. So those are both clustering problems. So with this seems very simple question, we can still frame it into quite many different ways. So in our case, because our goal is not really making money from Bitcoin, but just to learn data science or data engineering from it, so we've framed it in a very simplified way. It's probably oversimplified. So we just want to predict whether a given order is likely to essentially make money or not. So as you can see here, we have the training data is a bunch of orders. So for each order, we know the price we made this order, and the market open price, and the high and low market price of that day. We also know the price points, some historical price points. So we have many orders like this, and we already know whether each order we have made a profit or not. It's flagged as true or false. So naturally, if we have a new order, we know at this moment what the price of the Bitcoin is. We know the market open price of this day. We know that the daily high and low. We also know the historical price just before we are about to make this order. So we can just use a binary classification to predict whether this order is likely to be profitable or not. So this is probably oversimplified way, but I guess for our purpose is just to make sure that everyone understand this machine learning problem and the data we have. So from the engineering part, so we can look at the architecture. So here, don't worry if some of you not familiar with all of the AWS services here. So I'm going to go through some of the services in more depth later. So what we have here is we have this overall architecture. We have a streaming client which subscribes to the real-time Bitcoin price data source, which is which uses a technology called Light Streamer. So there's a question here: what is the holding period in this model? How long you hold before selling? Yeah, it's a good question. So for this demo, actually this streaming client here are creating a bunch of mock-up transactions. So it has as a mock-up transaction, in the mock-up transaction rule, we have set rules like if I made $10 in this transaction, I sell. If I have lost, let's say $5, I sell 2. So in this way, in this way, we can collect the data. We collect only the completed transactions. So each one is already closed. So each one has been bought at a price and sold at a price $10 higher, or either $10 higher or $5 lower. So I guess that answers your question. So this mockup transaction client generates this mockup data. And over the time, we will have more and more data in our S3 bucket, and this client will batch up the data and put into S3 as CSV files. And those objects in S3 will trigger a Lambda function. The Lambda function triggers the AWS step function, which is the main part of the automation pipeline. So as the first step of the step function, it first checks whether all the input files have been received and whether they are correct, of course. And the next step, it starts a glue ETL job execution. So glue ETL is a fully managed AWS service that does ETL, so extract, transform, and load jobs. But of course, in our case, we mainly use as a data transformation component. So this glue ETL job essentially transforms the CSV files. In the raw file, we have transaction data as well as price data. So this ETL job will join these two data and fill in some missing data and do some other sort of transformation. For example, scanning the data, normalize the data, and split the raw data into training, validation, and test the data set and put in S3 again. So this is a glue ETL job. And when the glue ETL job is finished, it starts a hyperparameter tuning job in SageMaker. So hyperparameter tuning job is managed components in SageMaker that essentially manages and creates multiple training jobs and try to find the best combination of hyperparameters based on some criteria you define. And after all the training jobs complete, we have a Lambda function where we define the model selection criteria and select the best select the best model based on the training result. And finally, we deploy them for prediction. And the inference endpoint will also be held in SageMaker, and we can just call this inference endpoint with the data format we introduced before, and it will give us a prediction result, whether, in this case, whether true or false, whether the certain order is likely to be profitable or not. So this is a high-level view of the solution, but I'm going to go more, into more depth into some of the steps later. So now we are going to look at a demo within AWS. So because although like the hyperparameter tuning takes, each training job takes only about 2 minutes, and the whole tuning process takes about 20 minutes, but the end-to-end process is still quite lengthy. It's maybe about half an hour. So we are not going to do the live demo today, but what I can show you is a demo that a pipeline that was recently completed. So this is the interface of step function. So as we introduced before, that's the main part of the automation here. So this is, you can see this is actually a complete pipeline. The first step of the pipeline, as we introduced before, is to check the input files. And we can see here, it checks, it found two input files. One is the price data, another is the transaction data, which is called deals here. Since this job has passed the input file checker, it starts the glue ETL job. So what we already talked about what the glue ETL job does. So if you are interested for the glue ETL job to work, obviously we still need to create an ETL script. And for this, we can still use some tools we are familiar with, for example, Jupyter Notebook. So this is my Jupyter Notebook. So as you can see here, I have put in the price data and the transaction data as we introduced before. And I have written some module here. And here you can see this is essentially the raw transaction data we have. And this is the raw price data we have. And then I joined the price data with the transaction data and did a bunch of other transformation. And eventually we get the data that is relatively normalized. There's another step of normalization SageMaker can automatically perform. So I did not do the normalization between the columns here. So this is essentially how I work out the ETL script. And I clean up the code and deploy this code in AWS Glue, which you can see. You can see here. So this is the Glue ETL job, and we can see like this, even the raw script here. So this is essentially just a cleaned up version of the script I just showed you in the notebook. And this is one job run, and we can see it's succeed. So the output of this Glue ETL job is again transform the data bank into S3. We can see the data is split into training, validation, and test data sets. And in this record IO format, that is a binary format this algorithm requires. And if we go back to the step function, we can see the next step is the hyperparameter tuning job. So this is the key of this automation process. So for some of you, you may have already used the hyperparameter tuning like locally. For example, if you use scikit-learn, you can do a grid search to find that best combination of the hyperparameters. So in AWS, this process, the advantage of using the AWS SageMaker hyperparameter tuning job is just that this whole process is kind of like already automated for you. So you don't need to create like multiple training jobs yourself. You don't need to worry about where you run those training jobs, because those training jobs will be automatically created and run on AWS infrastructure. So the tuning process is relatively fast as well. So as I introduced before, that each training job takes about, you can see the training time is only 60 seconds here. So you just need to pay for 60 seconds compute cost, which is relatively cost effective. And for the hyperparameter tuning job itself, it's actually free, because the only bill you will receive is the compute time that you spend to train those jobs. So for this hyperparameter hyperparameter tuning job, I set it to do 10 different trainings. So you can see there are like training job number 1, number 2, number 3. So the goal of the training is, of course, to find the best combination of hyperparameters. With that, I think I probably need to talk about the concept of hyperparameter tuning a little bit, although I know half of the audience already working as a data scientist, and you probably already know about hyperparameter tuning, but just conscious that maybe not everyone's equally familiar with this idea. So what's the difference between training and tuning? So training is, if you are in this talk, you probably already know training is a process that to find the best values for the parameter in a mathematical equation that is used in a machine learning algorithm. So for example, in a relatively simple example, a support vector machine algorithm here, the goal we have here is to find the line that perfectly splits the purple dots and the green dots. So from our mathematical knowledge, we know to define this line, we need a parameter which is W and a parameter which is B. So these two parameters together could define this line. So the training process essentially is to find the best combination of W and B. Of course, many machine learning problems will be more complicated than this. This is just one of the simplest examples. So, but on the other hand, tuning, the purpose of tuning is find the best combination of hyperparameters. So hyperparameters, they are the parameters outside those mathematical equation. So it's not it's not within the equation itself, but it has an overall impact on the model training. So essentially, it teaches the machine how to learn. For example, some of the common tunable hyperparameters are the learning objectives. For example, if you want to maximize the precision, or whether you want to maximize the precision, or whether you want to maximize the recall. So in our case, to predict whether a Bitcoin order is likely to make money or not. In our case, the precision means how many of the orders the algorithms say would make a profit actually turn out to make a profit. So that is how precise the prediction is. And in this scenario, the recall means how many of the profit-making opportunities the algorithm has identified. So in an ideal world, of course, we want to maximize both the precision and the recall, but in reality, a lot of times we may need to balance the precision and the recall. So that's why the learning objective is not immediately obvious. So we need to tell the machine, okay, whether we want to maximize the precision or whether we want to maximize the recall, and whether we need to find the balance. And another common tunable hyperparameter is the batch size and epoch. So essentially those parameters determine how fast the machine can learn, and also there's learning rate. Learning rate determines essentially how quickly the machine jumps to a conclusion. For example, you can have a training problem that the data may say, okay, 10 girls are wearing pink, And if the learning rate is high, the machine jumps to conclusion very quickly. Okay, it may get a conclusion all girls wear pink, but obviously from common sense, that's probably not the case. So we may want to lower the learning rate. In this case, the machine will get a conclusion that, okay, actually there's a 10% increased chance girls might wear pink. But it's not always the learning rate, the lower the better, because if we just lower the learning rate, we may end up having a model that is very indecisive. For example, for those who have Alexa at home, if every time you ask Alexa just say, sorry, I'm not sure. Obviously, that's very frustrating as well. So that's why we need to find the right balance of the learning rate. And regularization is a technique that we use to reduce overfitting. So those are the example of hyperparameters. The process of hyperparameter tuning is essentially to find the best combination of hyperparameters, or sometimes just the best value for one hyperparameter you want to tune around. So that is the hyperparameter tuning step. And end of the when all the tuning jobs are complete. So in SageMaker, how it finds the best combination of the hyperparameters is it uses a algorithm called Bayesian search. So Bayesian search is an algorithm originally designed to search for missing objects in a multi-dimensional space, and in our real world, of course, a three-dimensional space. For example, if a plane went missing in the sea, and we need to run a search to find this missing plane. So this is how what this Bayesian search originally designed for. So in our case, it's used to find the best combination of hyperparameter in a multi-dimensional space. So it's a similar problem, although it sounds quite distant. So this is also like a unique point SageMaker offers, as opposed to running a grid search, which is essentially just like a brutal force search. So when you run the hyperparameter tuning, how it works is it will first start one training job with a random combination. And from the second job, it's based on the previous experience or previous observation. In this case, the first training job, it finds the next proverb better combination of hyperparameters, and it goes on like this iteratively, and until it finds the best possible combination within the limit of the number of training jobs you have. So after all the training jobs are complete, we can actually see the performance of all these training jobs in Cloudwatch. So Cloudwatch is an AWS service where you can see the logs and the metrics of different services. So as here you can see there are a list of training jobs, and then we can just look at the test precision, the metric that we care about. And because this job was run, those hyperparameter job was run a few days ago, I need to go back a few days to find this data. As you can see here, in the training job number 1, the precision in the test data set is actually 78%. That is pretty good. But gradually, as the hyperparameter tuning job finds a better combination of hyperparameters, the precision actually increased. Like for example, you can see here in the 6th training job, the precision is 86%. So this is the hyperparameter tuning. And after that, all we need to do is just to select the best model and create endpoint from this model and use it for prediction. That's pretty straightforward from there. And I think like as a discussion point, as at the beginning I mentioned, there are some areas I think this model can improve as well. For example, this model probably suffers from some overfitting, and the price alone is probably not the best feature for this kind of prediction, because there is an issue called multi-collinearity, and also I may need to do some better feature scaling to improve this model. But nevertheless, I think it's still satisfied its purpose. So if from that's essentially the end of my presentation. And if you have any questions, feel free to ask in the chat. And apart from this, I just want to mention a few learning resources that really helped me when as I introduced at the beginning, I'm not a data scientist by training. So there are a few resources I find I benefit from. So one of them is the AWS's free training site. So although it's training provided by AWS, it does not only talk about AWS. Actually, the first 3 I mentioned, like general machine learning topics here, almost does not talk about AWS at all. I think some of the courses are really good. Apart from that, I also would recommend the 100-page machine learning book, which is a brief introduction of some of the most noticeable machine learning algorithms from the data science perspective. And finally, the Google Machine Learning Glossary. I especially like the fact that it gives an outline how to evaluate the fairness in machine learning, which is a very interesting topic nowadays. With that, that's the end of my presentation. And if there's any questions, please type in the chat.
I don't think we have any questions. I know we're also live streaming on Twitch, but we don't seem to have any questions there either. Anything else that you like to add? Right, so I think we're done. Well, thank you, Yoyu, for your talk. Very interesting. You might be getting some questions directly, Yoyu, because
yeah, I think there are a couple of questions from the chat.
Yeah, I think it's not getting to everyone. I think it's probably going to you. So yeah, go ahead if you want to answer them.
So AWS SageMaker Autopilot, to be fair, I have not used, but I did use, I have used the Google equivalent of Autopilot. I think, of course, it's a very good service, as you just need to provide your data and the field you want to predict, and the service will choose the algorithm and different like hyperparameter for you. I think it's definitely a service worth trying. I think for this use case, as I said, the purpose was not to make money. So it's more like to explore the automated process, like the automated pipeline. But they are, although we are not really deploy this model for production, but I know there's in the industry there are some similar use cases like this. For example, the recommendation engine we mentioned from the very beginning, and also there's some fraud detection, anomaly detection, where people do want something that can adopt to new data sets. Would I use something else than AWS, I guess? Yes, actually, in my personal projects, I do not always use AWS. I think there are quite a lot of times I found just doing some work on my local computers, doing some training, exploration on my local computer, easy enough. And sometimes I also use Google's Colab notebook. So it's like a managed Jupyter notebook, but Google provides you some compute resource, even GPU, where you can train some simple models relatively effortlessly. Also, you don't need to worry about running the workloads on your local computer. Yeah, that is a service I recommend as well. But of course, there are equivalent services from other cloud provider too. Thank you. I think with that, we can hand over back to Belen.
Thanks, Zoe. So yeah, I think we're done. So if you're on the Zoom call, we can stay for some networking. So Zoom has a feature called breakout rooms, so we can divide ourselves into smaller groups. So just leave a couple of minutes for those who want to leave and who wants to stay. Yeah, please stay. The next event, it's on the 14th of July. It'll be around digital transformation. So you can check that on your local Meetup group or on Eventbrite. We'll be live on Twitch as well. I know some people are on Twitch because they had some issues getting into Zoom. So apologies about that. I will check what happened there. But yeah, looking forward to seeing everyone in a couple of weeks. If there is anyone interested in doing a talk, it'll be great if you want to send us a message. Whoever is on Twitch, Isa is going to put the details of the Zoom meeting there in case someone wants to join us for the networking part. So yeah, the details are gonna be there, and if you want to join the networking, just jump on the Zoom call.